Even though this is getting quite far from the ocean and atmosphere dynamics, I think the climate change topic is actually best discussed with all its aspects, because pretty soon it gets far away from the science of it and gets into the social science of it. So you might as well be exposed in your introductory course. Okay, the concept of detection and attribution were about the science of detecting change signals and then finding the causes for them, saying what could have caused the change. Is it human activities? That's the main question, right? The other thing relates to how we respond to climate change. So there are two things. One is called adaptation, where you say some change is happening already because of the carbon emissions thus far, so we better adapt to deal with the changes like the extreme rainfalls, droughts, hurricanes, cyclones, sea levels, etc. Okay, the other, so that's kind of managing the unavoidable things that are already here. The other is mitigation, where we try to actually reduce our impact on further climate change, and also what we have already done. So these two obviously are not completely independent of each other. You can see some examples here in adaptation. So mitigation is to try to avoid the unmanageable. Okay, so change in land use, relocation, emergency business and continuity planning, upgrades or hardening of buildings and infrastructure, residential programs, promoting adaptation, health programs. There are many things: fishing gears, agriculture, smart agriculture, smart cities, so on, and health issues, water quality, air quality, etc. Mitigation includes things like energy conservation and efficiency, so you reduce the emissions in the first place. Renewable energy, so reduce the carbon footprint, move slowly towards decarbonization. Sustainable transportation, improved fuel efficiency, again, reduce the number of cars, number of miles traveled, and more efficient transportation. Capture and use of landfill and digester gases and carbon sinks, so maybe afforestation to create new carbon sinks, recover the coastal ecosystems like mangroves and also wetlands and salt marshes, which actually sequester 3 to 10 times more carbon than the land forest, terrestrial forest. So those are kind of things that fall into mitigation, and there is intersection of these two, where let's say you seal buildings so you avoid energy loss or the heat loss during the winter, and heat coming in during the summer and so on, so you reduce overall energy use. There is also water recycling and so on and so forth. Green infrastructure, which in which buildings are built to reduce energy use in the first place. So there is the retrofitting, many of which are needed because the old buildings cannot simply be destroyed and reconstructed, but there is calculations to show that retrofitting can easily recover the cost in terms of saving the energy, water, and improving health, for example. Also the externalities, how do we count for reducing pollution, right, by reducing energy consumption? So that's not directly countable in the return on investments of retrofitting buildings, for example. Water and energy conservation, smart growth, I mentioned smart cities and so on. So these are both adaptation and mitigation. So avoid the unmanageable and manage the unavoidable. Okay, those are the key things. The IPCC reports have also started defining risks and vulnerabilities, and in this comment I'm just saying that if you're a country like India, you cannot worry about only your climate vulnerability and risk. For example, the extreme monsoon events are being fueled by ocean warming, which you cannot directly control. It's related to global activities, plus the vulnerabilities and risks of your neighbors will become eventually your problem. So you have to make plans that reduce the overall geopolitical risk and vulnerability that may be triggered by climate-induced crises like sea level rise or droughts, desertification, and so on. Okay. So what IPCC does again is looks at physical systems, biological systems, and human managed systems, and looks at risks, and it also provides the estimate of how much the risk could be reduced by adaptation and mitigation. Okay, so these are on the present, near term, so 2030 to 2040, long term with long term is 2080 to 2100, with global warming contained to below 2 degrees C or allowed to go up to 4 degrees C. Okay, so the risk level is shown here with very low and very high, and this is the potential for additional adaptation to reduce risk level. So there is already some adaptation built into the future projections, and then there is an estimate of how much additional risk reduction can be done by additional adaptations. There are criteria needed to choose, right? You cannot put all the money into mitigation or all the money into adaptation. Countries have to balance their economic growth ambitions, their living standards, gross domestic products, which is related to economic development, but food security, water security, national security, and so on. So very detailed calculations go into that. I just want to give you again the sense that in each region there are risks that are medium to high already. Very few regions have a low risk in either the physical or biological or human managed system, even in the polar regions, especially so in the polar regions because of the polar amplification and the vulnerability of sea ice in the Arctic and the glaciers over the Antarctic and associated ecosystems, right? So risks in the polar systems are high with very little room for additional reductions because of adaptation, but in human managed food production systems and livelihood and health or economics, there are ways to reduce these. Many countries are already beginning to act on them or at least plan for them, not only in the polar regions but even in the deep tropics where island states are worried about sea level rise. For example, Vanuatu has made plans to move all its citizens to some other island if sea level becomes so bad that the island becomes uninhabitable. Okay, so many detailed plans exist, and North America, you can see that each system has some room for additional risk reduction. For example, here increased damages from wildfires, heat-related human mortality, increased damages from the coastal and urban floods. Okay, river, coastal, and urban floods. North America now, especially US, is having fires looks like almost all year long. They used to have a specific fire season, but now the season extends much longer during the year. And this also relates in terms of fire potential. West Coast is dry because of the cold coastal waters, and the climatology itself is dry. And the dryness here, as we saw, is related to the state of the East Pacific as well. When there is an El Nino, they get additional rainfall, mountain snow, but in a La Nina, it is drier than normal. So if global warming ends up causing less warming or even cooling in the East Pacific, then California may continue to get drier, and there are predictions for projections of such a future. Okay, so those are the kind of risks and adaptation measures that need to be considered. For Europe also, water restrictions are some a risk and vulnerability, extreme heat events and wildfires, and in Asia, it's increased flood damage to infrastructure, livelihoods, and settlements, heat-induced human mortality, increased drought-related water and food shortages. So each place has slightly different impacts of climate and different risks and vulnerabilities which they have to plan against. Similarly, for the ocean, you have distributional shifts, reduced fisheries catch at low latitudes, increased mass coral bleaching and mortality, coastal inundation, and it's so hard to read, and habitat losses, and so on. Okay, you can go through this. IPCC report is really fantastic in terms of the details. Obviously, each country then has to decide for itself how it's going to choose between adaptation and mitigation, and whether it really has a choice. For example, if monsoon extremes continue to get worse and more widespread over India, then water resource is one thing where you have to learn how to capture the groundwater recharge from extreme rainfall, which are typically associated with larger runoff into the ocean than when the rain is normal. Plus, there is the damage to the crops and shifts in the rain, so that the crop calendar itself has to be thought about in a new way. Okay, so can the monsoon season be just used to collect rain, for example, and do agriculture during the non-rainy season with just irrigation? Then you have to worry about water quality as well, and so on. So these are complicated issues, and we don't have too much time, but I want to give you just a sense of how complicated the issues are and how local they are. So despite the global warming, all impacts are local. So all plans have to be done locally as well, which means models have to get better and better at projecting local impacts and local solutions for adaptation and mitigation.